Hello everyone, welcome to NEET Academy. As we have discussed in the previous lecture, electrophilic substitution reaction, right? Actually, that is mono substitution reaction. Today we will discuss if one substituent is present, then another incoming electrophile will attack at which site. So, single then double we will discuss. Okay. Electrophilic substitution. 5 we have discussed. Suppose we are having mono substituted. Suppose we are having benzene and it has been already substituted by CH3, that is toluene. Whole is known as toluene. Okay. Suppose we are having further electrophilic substitution. So total we are having 5 sites, 1, 2, 3, 4, 5. So this incoming electrophile will come at which site out of all these 5, right? So that will depend, the incoming of this electrophile at all these sites will depends on the nature of this substituent. CH3 is known as orthopara directing. What does it mean? It means for a mono substituted benzene, if we are doing the further electrophilic substitution, the incoming electrophile will attack at either of all these 5 sites, depends on the nature of this substituent present already over the benzene ring, right? So the nature of this methyl is orthopara directing, means it will direct the incoming electrophile to attack at ortho and para position only. So as you all know, 1 and 5 ortho position, actually not 1, it is just for the counting purpose, it is not actual counting will start from here, but for the purpose, for the sake of convenience, I am just telling 1 2 3 4 5. Okay. So in this, actually rather what we are having, if a benzene ring is already being substituted by any substituent, so this is the first position, 2 3 4 5 6. So for this example 1 5, but here 2 6 is the ortho. Actually in all notation this is must be followed. Okay. So it is orthopara directing, and as per this notation is concerned, 3 is the para here. So the product will be CH3 E plus CH3 E, and in most of the cases para is major while this one is minor, and for the reason to be minor is steric factor, right? On account of steric factor, ortho isomer is less. So let us examine how the incoming electrophile is coming at ortho or para position, right? So I am taking one example, this one. This is, let us say, NH2 I am taking this time. This is also orthopara directing. let an electrophile is coming to attack. Okay. So what will happen? This bond will clip by this way. As soon as this bond is clipped by this way, positive charge is developed here. Positive charge is developed here and negative charge is developed here. So what happens actually? This attacks here, and as soon as the positive charge being developed here, this lone pair involves in bonding. So we are having this NH2, since it's one electron being involved, so it will have positive charge and electrophile will come here. And hydrogen is also here. So actually, before going to lose this proton, that is electrophile, that is H plus, it is being resonance stabilized. Just see how this bond clips by this way, lone pair involves in bonding. So this is the next step, NH2 plus, and it's developed negative here. Then further conjugation, that is resonance, will take place. This bond will clip by this way, positive develops here. At adjacent you are already having negative, so plus minus gonna make a bond. And this time negative charge moves here. Okay. Then further we are having, so on account of this cleavage, we are having NH2 plus and bond here, bond already here, and negative moves here. So you could see nitrogen is an electronegative element, cannot possess positive charge for long time, so it regains its lone pair by cleaving this way. So positive comes here, then plus minus going to make a bond here. So you are having original structure by resonance stabilization. So what you can observe from here to here, what you can observe in the sigma complex, the negative charge is developed at ortho and para position only. You can see in this one this is ortho, in this one this is para, in this one this is ortho. So negative charge is developed at ortho and para position, and you all know electrophiles are electron deficient, will always attacks at the site where the electron density is maximum. So it may either attack here or here, give rise the single product, and if attacks here, give rise one more product. So here we can have, when ortho attack being taking place, okay, now this hydrogen will lose to regain the aromaticity. So you could see this is E, this is NH2. This is what we call ortho isomer. By the same way, if this electrophile attacks at para position, we can have para derivative. Ortho is always minor, sorry, most of the cases minor because of steric reason. Okay. Now let us see if two substituents are already present over the benzene ring. When two substituents when two substituents and we'll have three cases here. Okay, so case 1. Case 1. One is ring activating and other is ring deactivating. Okay. Now we'll take an example. Suppose here you are having CH3 and here you are having CN. You know, all ortho-para-directing substituents are ring activating, while all meta-directing substituents are ring deactivating. It doesn't matter whether it is strongly activating or weakly activating. It only considerable when both are same, means both are ortho-para-directing and both are meta-directing. Then only it is considerable. Otherwise, if both are opposite, then there is no issue. Suppose an electrophile is coming to attack over this substrate, right? So now the question arises कि this electrophile will come here, here, here or here. Actually, after the dye substitution, we are having the 4 available sites. Okay. So out of these 4 available sites, this electrophile will come at which site? So that is, you know, orientation. Orientation is decided by either this one or this one. So the major point is here, this is activating and this is deactivating. So the orientation for incoming electrophile is decided by that substituent which is activating. So you could see this one is what? Ortho-para directing. So with respect to this one, further electrophilic substitution will take place, right? So with respect to this one, this is ortho, and this one is para, right? So 3 isomer will form here. 3 isomer will form here. So I'll write all the isomers CH3 CN plus CH3 CN plus CH3 CN. 3 isomers will form. How? Just see. These two are ortho. So one electrophile will come here, and in another one the electrophile will come here, and in another one the electrophile will come here, because with respect to this one only this site, with respect to this one this site and this site are the available site. This one is not, because this CN is going to deactivate the ring. So here the incoming electrophile will not come. Okay. Now this is the least, because of the same reason, that is steric reason, and para is the major. Sorry. With respect to this one, these two are ortho, this one is para. So this one going to measure, this one is minor, and this one will form in the least proportion. Okay. So question being asked generally in JEE and NEET ki how many possible isomers are there for this electrophilic substitution, and sometime it may also ask ki which one is major product likely to form. I am in the standard form saying E plus. What does it mean? We are having the total 5 electrophilic substitution reaction, that is Friedel-Crafts alkylation, Friedel-Crafts acylation, halogenation, sulfonation and nitration. So in the previous class I have discussed already in which electrophilic substitution reaction which type of electrophile being formed. Okay. So as per this very electrophilic substitution is concerned, these two are present and the orientation for incoming electrophile is determined by CS3. Listen it once again. CS3 is activating, so the product will form as per its direction. So it directs the incoming electrophile at ortho and para position. So this is para position for this one. So ortho and para. So 3 products will form. This one, because of the steric reason, will be in the least proportion, while that too ortho is major and para is major and ortho is minor. Let us have one more example. Suppose you are having this one. Now the incoming electrophile as in the previous case, right? So now let me know how many products will form in this reaction. Total 4 sites are available, 1, 2, 3, 4. So let me know at which sites this E will attack. Again, because of ring activating and ring deactivating, the incoming electrophile will be directed by CS3. So CS3 is ortho para directing in nature. So only ortho sites being available, para site is blocked, right? So in this reaction, only one product will form. In this reaction, only one product will form, that is, you must join electrophile here or here, both giving rise the same one. Okay. Now case 2. Case 2. When both are ring activating, both substituents are ring activating. Okay. Just see. This is OH, and let's have one more, that is CH3 here. That what we call is metazylene, sorry, metacresol. This is what we call metacresol. Now electrophile is coming for the further substitution. Okay. So think of it ki this electrophile will come at which side, because this is ring activating, this is also ring activating, but as per the relative ring activating power is concerned, OH is more activating than CH3, right? So incoming electrophile will come at as per the direction of OH, and OH is ortho para directing. So again, this one and this one being ortho and this one being para. Okay. So again in this case 3 products will be there. Again you could see 3 products will be there. This is OH, this is CH3 plus this is OH, this is CH3 plus one more OH and CH3. Okay. So insertion of this electrophile at this site or this site or this site will take place. So let us form them. E, then E, then E. Obviously this one is going to be major, this one is going to be minor, and this one is the least proportion. Okay. So what you have to observe in tri-substituted benzene and its derivatives, if two substituents are already present, so you have to observe ki what's the nature of these two substituent. As in this case both are ortho-para directing, but OH is more, so the product will come as per OH, right? Now what if both are ring activating? Case third, both substituents are ring deactivating. Okay, just see, let us see Cn here, here NO2. Both are ring deactivating and meta directing. Ring deactivating and meta directing. Now suppose the further electrophilic substitution being carrying out, right? So let me see where this incoming electrophile will come. As I said, you have to observe which one is deactivating the ring up to the greater extent. So this is NO2 more deactivating, activating, right? So the product will come as per less deactivating. So Cn is here less deactivating and it is meta directing. So with respect to this one, these two are meta. So meta position being already blocked, this one, but here it is free. So incoming electrophile will come here only. Okay. So the product in this case will be Cn NO2 and incoming electrophile will be directed by Cn. So this is the final product and major one. Okay. What is the basic use of this directive effect in benzene and its derivative? One of the use is there in conversion. Very important for JEE. Suppose you have to carrying out this conversion. You are having toluene and you have to obtain COOH-Br. You have to bring about this conversion. What happens actually in JEE Advanced and JEE also, the question comes and options are given, which among the following is the suitable set of reagents required for this conversion. So as you all know, methyl oxidation of methyl over the benzene ring directly converts it into carboxylic acid and it is ortho-para directing. So just do the bromination of this one, and after bromination oxidation this one, you will get this one. But unfortunately that is going to give you very minute conversion product, and we have to maximize the yield, and we do not require any product at para position. Rather I would like to say we do not want to consume toluene even a small fraction. So what is the influence of the directive effect? First of all, block para position. So H2S2O7. Actually, SO3H, this one, SO3H is used to block the para position and can be removed. This is the insertion at para, and if you want to remove this one, so it has to be heat with H2SO4 and steam. So it will leave the site also. So first we are just introducing just to block this para position. So what happens here, just see, this is CH3 and SO3H here. Okay, now just see, now it's become di substituted, getting. Now do the bromination, electrophilic substitution, bromination in the presence of Fe in dark. Okay, so what will happen? This is ring deactivating, this is ring activating. So product will form as per this one. Product will form as per this one. So what we are having, CH3Br comes here without having any para substitution, because para is blocked by sulfonic acid SO3H. Via this one we have blocked it. Okay, now do the oxidation. MnO4 minus H plus, what happens? This oxidized to COOH group. So just see, orientation help us to carry out this conversion. Now SO3H, now heat this one with steam and H2SO4, desulfonation will take place, this will remove from this side and you will have this product, right? So this is what the beauty of directive effect in conversion. This is very very important for JEE advance also. Okay, now let us have